Alright guys, it's time for AppMath 头要痛了 ah. Okay, so I hope you already finished the indices. Alright. For those who have not completed the indices, please make sure you do first before you learn about Surds. Alright, if not it's gonna get even more complicated for you all. Okay, Surds. Okay, so what is the meaning of Surd? Actually, Surd meaning is this symbol. Okay, this is what we call Surd. Alright, so normally Surds we can write it in different form. Surd 3, Surd 4, sorry, not Surd 4 is not like that. Surd 3, okay, Surd 4, alright, Surd 5. Okay, this is what we call Surd. Okay, so normally if how do we read this is, let's say for example like this, right? This one, yeah. Okay, this one, how we normally interpret it or how we read it in words, this one is when we write it in words, we call it Surd 9, order 5. Okay, so the one in the Surd 9, order is this one, the power here, 5. Okay, so if you see in your question, they ask you or they write it in this form, make sure you know how to convert it into this form. Okay, so Surd, the first thing that you need to know is how to identify whether the numbers or the terms given are they a type of Surd or not a type of Surd. So there are conditions here. Now for Surd to be considered as Surd, it must be irrational numbers. Okay, irrational numbers, meaning this one you cannot, okay, this one cannot convert to fraction. Okay, that is the meaning of irrational numbers. Alright, numbers that can be converted to fraction, we call them rational numbers. Okay, and then the second condition for Surd is that non-recurring decimals. Okay, non-recurring decimals is that you will see your decimal, for example 0.21567, then got a lot one at the back. Okay, this is non-recurring decimals. If recurring numbers is meaning this one. Okay, so if you see here, you will notice that the 676767, this one is actually repeating. Alright, so this one is considered as recurring numbers. So if it's a recurring number, this is not a Surd. Okay, and then integers, meaning if you can do the Surd, for example, Surd 4. If you do Surd 4, you will get 2, right? So this is an integer. So meaning this one is actually, we do not consider it as a Surd. So you only consider as Surd when number 1, you get irrational numbers. Okay, cannot convert to fraction, not recurring decimals. So these two things. Okay, and not integers, obviously, right? Okay, so let's look at a few examples here. So determine whether the following terms are Surds. Give your reason. Okay, so for example, Surd 6, you press your calculator Surd 6, tekan, okay, you will get your answer is, for example, 2.4494, okay, a lot. So this one is a Surd. Okay, the reason being is that it is a non-recurring decimal, or we can say is irrational numbers. Okay, because this one the answer is an irrational number, meaning I cannot convert this one into a fraction. Okay, what about Surd 81? So if you Surd 81, you will get your answer is 9, right? So this one is not a Surd because number is integer. Okay, the final answer that you will get is an integer. Okay, so that's why this one is not a Surd. Okay, what about this one? Okay, Surd 125 to the order of 3. So if you press your calculator, Surd 125 to the order of 3, this one I believe you will get is 5. Okay, so this one, Surd 125 to the order of 3, you get number is 5. So this one is not a surd because 5 is an integer. Alright, so what about this one? Surd 1 over 9. Now if you press surd 1 over 9, I believe you are going to get a fraction here. Okay, so if you press surd 1 over 9, you are going to get 0.3333 and then non-stop 3, I think. Okay, a lot of 3. So this one is considered as a recurring numbers or recurring decimals. So this one is not a surd because it's recurring decimals. Okay, alright, what about surd 3 to the 4? If you press surd 4 to the order of 3, you're going to get, so this one you will get 1.5874 something lah. So this is a surd because this one is an irrational number. Alright, so this one obviously is a recurring number, right? So this is not a surd. Okay, so the reason is because it is recurring numbers or recurring decimals. Alright, so that is the first part. Okay, meaning you need to be able to identify are the terms given surd or not a surd. Okay, so you just based on these two things lah. If you get rational numbers or what you call recurring numbers or the final answer is an integer, so that one is not considered as surd. Okay, only when you have a lot of decimal place and you cannot convert it into fraction, okay, then you consider them as surd. Okay, so this is the first part of your surd. Alright, so in your syllabus, they will require you to learn how to convert recurring decimals to fraction. Okay, now when we say this is not a surd because of recurring decimals, right, meaning that this one is actually a rational number. If we say rational number, meaning that this one you can convert it into fraction. But how can we convert this into fraction? Now, if you press in your calculator, right, if you only press 0.676767, they won't be able to change it to fraction. You need to press, I think, 8 times, meaning 8 times 67, 0.6767676767676767, many 67s, and then when you press the enter, right, then only they will be able to convert it into fractions. If you only type 3 in your calculator, you won't be able to see the fraction one. Okay, but you need to learn how to convert this manually, okay, without using your calculator. Alright, so I'm going to show you how we convert the recurring decimals to fractions. So two examples. Okay, first one is when you start off with 0. Okay, so how do we convert this one? Alright, so I'm going to show you how I do this. 0.242424, and then they put dot. Alright, so how can I convert this into fraction? Now first things first, okay, I want you to look at the repeating number. You need to identify which is the repeating number. So if you notice, right, the repeating number is here, 24, 24, 24. Okay, meaning it's 2 decimals, right? Okay, meaning you are repeating this number, 24, 24, 24. So what you're going to do is you're going to shift the dot to this part, okay, to the first decimal point here, decimal place here lah. Alright, so you're going to multiply to 100. So we're going to do this. Okay, we are going to make it into like this. So let us assume, let's say I put an unknown is equals to 0.242424. Okay, and then I already know that my repeating number is 24, right? So I'm going to multiply it to 100. Okay, so this one will become 100a equals to 24.242424 dot 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 lah. Okay, so this one will be my first equation, this one will be my second equation. Now the reason why I need to do this is because I want to remove all the decimal place at the back. So how I do this is when I take equation 2 and then I minus equation 1. Okay, what happens is that you are going to minus this thing off, because 24.242424, if I minus 0.242424, basically you're going to cancel off the behind part, all of this, only left with 24. Okay, so take equation 2 minus equation 1, this one will become 99a equals to 24. Okay, so a will be equals to 24 over 99. So this is the fraction. Now if you can simplify this fraction, then you can try and simplify. Okay, I think this one I can simplify because it's 24 and 99. So let me just try, if I divide 3, this one will become 8, this one will become 11. So this is my final answer. So this will be the fraction. Now if you want to test and see whether your answer is correct, what you do is you press in your calculator 0.242424242424 at least 8 times, then only you will be able to get the same answer. Okay, alright. 242424 divide 3. Oh, sorry, it's not 11. It's 33. 33. Okay, because I divide 3, so it should be 33 here. Alright. Okay, so 24242424. Then this is how you actually convert what they call an recurring decimals to fraction. Okay, so basically this is the method lah. Alright. So I'm going to show you the second one. Okay, so just off this first. Okay, the second one, this one, 12.345345. So how do we do this? Okay, 12.345345. So what I'm going to do is I'm going to separate the 12 from the decimal. So I'm going to make it into like this. This one is equals to 12 plus 0.345 like this. Okay, and then I'm going to do the same thing like I did earlier on. I'm going to assume, okay, a is equals to this one, 0.345. Okay, and then I'm going to find where is my repeating decimal. So if I see here 345, okay, so 3 place, right? 3 place meaning I need to multiply by 1000. So I multiply 1000, and then this one will become 345.345. So this one is equation 1, this one is equation 2. And then I take equation 2 minus equation 1, what do I get? 999a equals to 345. Then a is also equivalent to 345 divided by 999. Now can we simplify this? So let us check. 345 divided by 999 is also equivalent to 115 divided by 333. Okay, but remember this one is for a, right? We still have the 12 here. Okay, so 12 plus a, this one you will get your fraction like this. Okay, so this is the fraction for the recurring decimals here, right? Technically this is how you do it lah. Okay, now if you notice there is actually a trend here. If you notice carefully, if you look at the answer for this part, okay, you will see that this one 2 places, right? 2 decimal place. So it's 24 divided by 99. Now, if you look at the third question here, 3 decimal place, right? So you are going to divide to 3 9. So there is actually a trend here. Okay, so let's say if I have another recurring decimal, let's say for example 0.55855585. Walao. Okay, like that. Okay, don't write too much. Pening. So if you see here, alright, so my recurring place is here, right? 55855585. Okay, so once I know that this one is 4 decimal place, right? Meaning I can know that my answer is immediately is 5585 divided by 9999. Okay, so you just press your calculator, see whether you can get your simplified version lah. Alright, but if this one is for you to immediately know your answer, but if you need to do the working, you need to show it out like this. This is the working. Okay, but at least you can know what is your final answer lah for this part. Okay, you just refer how many decimal place, then definitely you have the same number of nines lah. Okay, so that is the first part on how to change a recurring decimals or recurring what do you call decimals to fractions. Okay, so that one is the first part. Alright, so the second part will be, okay, so let's look at, so you can try these two questions on your own. Alright, so now we are going into the third form. Okay, so for the operations of surd, okay, these are the two operations that are going to use. Okay, so when you have surd A multiplied by surd B, you just multiply the one inside. Okay, and if it's divide, also the same thing, you divide the number inside, right? So in this case, I can just do it like this. So we just multiply the number inside. 7 multiplied 6 is 42. That is your answer. Okay, this one meaning 24 divide 3. So this one I think answer should be 8. Okay, so this is what they want. Write it as single surd. Okay, meaning you just leave it like this. Don't have to simplify. If they ask you to simplify, then only you simplify. Alright, but if they only ask you to write it in single surd, meaning you just leave it like this. If simplify, you need to continue doing it. Okay, so how do we do simplification? Okay, so this one all you don't have to simplify. You just calculate and make sure that your answer is in a single surd form like this. Okay, like this and like this. Alright, so for simplification, okay, we are going to use all this to do simplification. Right, so if you multiply the same surds, you're going to get back the same number here. Okay, meaning the number A here alright, and then if it's plus, meaning it's 2 surd A. Remember always check what is the sign here and here totally different meaning alright. Okay, this one is when you have plus and minus, meaning it's either when it's plus or minus, you just take the number in front, you either add up or you minus. Okay, and then just leave it in surd A like that. Okay, so I'm going to show you how I'm going to do for these 3 questions. Alright, surd 24, surd 63 order 5, and this one. Okay, so I'm going to show you the first one, which is surd 24. Okay, so first thing you need to do is you need to factorize the number inside. So how do I factorize the number inside? Remember, you can do it in many ways you can either 12 multiply 2, 6 multiply 4, 4 multiply 3. Doesn't matter if you're going to get back the same answer. So I'm going to show you one of the examples. Okay, let's say if I take 4 multiply 3. Okay, not 4 multiply 3, should be 8. Alright, so 8. Okay, so if I take 8 multiply 3, meaning it's surd 8 multiply 2, surd 3. Oh my god, what is wrong with me? Surd 3, okay. And then surd 8, if I simplify it further, this one is surd 4 multiply surd 2. multiply Surd 3. Okay, meaning I change the Surd 8 into this one. I factorize again. Alright. Now Surd 4 I already know is 2. Okay, multiply Surd 2, Surd 3. So this one, when you multiply different surds, multiply the number inside. So the answer here will be 2 Surd 6. This is your final answer. Okay, so let's say if I try use another one. If I use, let's say 6 and 4, meaning I take Surd 6 minus, multiply Surd 4. Alright, so Surd 6, okay, I leave it in Surd 6 lah. I don't need to purposely factorize also. Okay, because this one, immediately I get is Surd 2 already. So Surd 2 multiply in, not multiply in, Surd 4 is equal to 2. So 2 multiply Surd 6, this one is your final answer. Okay, let's say if I try 12. If I try 12 also can, just that the steps will be longer a bit lah. Okay, and then I factorize the 12 again. So 4 multiply 3 multiply 2. So again, this one is equals to 2. Then this one you multiply the number inside. So you get back 6 also. Alright, so if you can see here, all you will get back the same answer. Okay, so technically this one normally if you press your calculator, right, you will be straight away get your answer one lah. Especially for example here is Surd 12, right? You type Surd 12, then you will get 2 Surd 3. Okay, so 2 Surd 3 multiply Surd 2, you will become 2 Surd 6. Okay, so technically that one is your first question on how to calculate, how to simplify the Surd form. Okay, so second question, this one, when you have the number outside. Okay, now first I need you to differentiate. This one is not the power. This one is not equivalent to this one. Okay, this one is 5 times Surd 63. This one is Surd 63 to the order of 5. So these two things are different. So please make sure you understand or you differentiate the two things. Okay, right? Alright, so let us start with this one. So this one, first things first, you need to factorize the number inside. Okay, so I'm going to do this. 63. So easiest to calculate is 9 times 7. Okay, you can just put it like this. Alright, so Surd 9 is also equals to 3, right? So meaning 5 multiplied to 3 times Surd 7. So this one is 15 Surd 7. So this is your final answer. Okay, simplification. Alright, next one, C. You have 3 Surd 20 plus 7 Surd 20. Okay, so this one, you are going to use the relationship here. Alright, so you are going to use this particular relationship here. Okay, you add the number outside, then Surd, you leave it outside. Okay, so here you add the numbers outside. Alright, so it's 3 plus 7 Surd 20. So this one will be 10 Surd 20. But this one is not done because they ask us to simplify. So meaning I need to simplify this part here. So 10, if I simplify, this one can be 5 times 4. Okay, so this one is equal to 2, right? 5 times 2. So this one is multiplied to 10. Remember, if you multiply at this, you multiply outside. Alright, so this one will be equivalent to 20 Surd 5. So this one is the answer. Okay, so technically that is how you simplify your surds. Alright, it's not as complicated as your indices. Actually, surds is actually much more, I feel it's much more easier to do. Okay, so you can try and simplify everything. Okay, you try and what do you call, factorize the thing. For example, like this one, right? 6 Surd 6, and then this one is 6 Surd 24. So what you can do is you try and make Surd 24 so that you can get the same term as this one, Surd 6. So you know, right, 6 times 4 is 24. So you can change it into that one so that you can use this one. Okay, so you can try it on your own first. Okay, I'm going to discuss this. I'm not going to. I'm going to show you how I do all this later on, right, on another day lah. Okay, so you try and do all the simplification first, and then once you are done with the simplification, then you can continue with the rationalize. Okay.
Alright, so if you already completed and done with the simplification of surds, you can continue to this part, which is the rationalized denominator. Now, what do we mean by this rationalized denominator? Actually, what they mean is to eliminate surd from the denominator. Okay, denominator, alright. Denominator. Okay, so meaning if I have surd at the bottom, I don't want the surd. I want to remove the surd. That's the meaning of rationalized denominator. Okay, so how I'm going to do this is I'm going to multiply the surd with their conjugate surd. Okay, so if for example this one is surd 10, right? Meaning I'm going to multiply to the conjugate, which is surd 10 over surd 10 lah. Okay, so in this case, for example, this is plus, meaning it's this one. Okay, so the conjugate surd that I'm going to multiply is negative. So meaning this one I'm going to multiply to surd 7 minus surd 2 over surd 7 minus surd 2. Okay, so remember when you want to rationalize the denominator, you multiply to its conjugate surd, meaning the opposite. If you have a plus at the bottom, you multiply to the negative one. If you have a negative here, here you multiply to the positive one. And then remember, when we multiply, we always multiply top and bottom. Okay, that is why you will see in this form. Okay, so I'm going to show you how I'm going to do this. So for the first one, okay, how I'm going to rationalize the denominator. Alright, so sorry, I'm just going to remove this first. Okay, so for the first question, how I'm going to do this. Okay, so 5 over surd 10. So I'm going to take this and I'm going to multiply to its conjugate surd, meaning surd 10, the one at the bottom. Okay, so after you multiply, because this one is the same thing in the surd, so it's left with 10. Then top will be 5 over surd 10. Okay, this one you can simplify. Alright, so this one will be surd 10 over 2. So this one will be the answer. Now, what about for the second one? Okay, 15 surd 7 plus surd 2. Okay, I'm going to multiply it to its conjugate surd. So, meaning surd 7 minus surd 2, surd 7 minus surd 2. Okay, so I'm going to multiply the one in the bottom. So, you're going to do like something like a quadratic equation. Okay, there's a reason why we multiply the conjugate surd. So, I'm going to show you this part here. Okay, so this part here, I'm going to show you. Okay, so when you multiply it like this, alright, it's like normally how you do for your quadratic equation. 7 multiplied to surd 7. Surd 7 multiplied surd 7, same thing, right? So 7. Okay, surd 7 multiply surd 2, so it's negative surd 14. This one multiply surd 14. And then this one, surd 2 multiply surd 2, you get back the same thing also. So surd 2. So you notice that this one in the middle we can cancel out already because it's minus surd 14 plus minus plus surd 14. So this one will be equal to 0. So this one will be equivalent to 7 minus 2. Okay, this one is 2. Okay, that, right, because Surd 2 minus Surd 2 you get 2. Surd 2 multiply Surd 2 you get 2. Okay, so that is why at the bottom, the part there, okay, we multiply to its conjugate Surd, so that we can remove the one in the middle. So when we say rationalize, meaning in your denominator, we don't want to see any Surd value in the denominator. So your answer here is 7 minus 2. This one is 15. And then multiply Surd 7 minus Surd 2. Okay, so this one is also equivalent to this one. This one I can simplify, cut. So this one will be the final answer. Okay, so that is rationalized denominator. Okay, so remember you need to multiply to its conjugate Surd. Now when you don't have any plus or minus, meaning only one symbol like this, you multiply to the same thing. Okay, if you have plus here, your conjugate Surd will be minus. If you have minus, your conjugate Surd will be plus. And the reason why we multiply to your conjugate Surd is because we don't want the middle part here. We want it to cancel off. So immediately I can get is the first and the last term only. Alright. So here, a few questions here. Let me just go through. Okay, there's a mistake here. This one should be Surd 7. Okay, not 7. Surd 7. Alright, so if I look at the bottom here, okay, for example, like this one, right? 3 plus Surd 2, right? So if I multiply to its conjugate Surd, it will be 3 minus Surd 2 over 3 minus Surd 2. Okay, so you can try and do the rationalized part first. Okay, rationalize is very important. Normally they'll ask a lot in your exam. Okay, so if you already finished the rationalization part, you can try and solve the equation if you know how to do it. Okay, but if you don't know, don't worry, I will show you later on also, but you can try first. Alright, so it involves a little bit of your quadratic information. Okay, how to calculate quadratic formula. Okay, there's a relationship there. Alright, but no worries, you can finish up to your rationalization of surds first. Okay, so that will be it for your MS today. Okay, bye.